All right, we're starting chapter 4, which is operations with fractions. Basically, the whole chapter is doing stuff with fractions. First of all, you should plan on not, in my classes at least, plan on being able to do all this without a calculator. So fraction key, sorry, off limits. Good to know kind of what's going on and so on. The other thing I wanted to say is a lot of people are really intimidated by fractions. You've done it for years. For some people, it just really hasn't clicked. For me, I probably equate this most with English grammar. I remember middle school, high school English grammar really never made a ton of sense to me. I worked hard at it and just didn't really do that well. For me, it really started clicking when I was in college. I was taking English 100 at Calvin College from a German professor, and it really just started making sense, where I'd get marked down for comma splices, and I just didn't know what a dependent and an independent clause was. Finally, it started to click. And for some of you, that may be the case with fractions, that before it hasn't made sense, but maybe now, maybe I will explain it differently and that will help. Maybe your brain has just developed a little bit further and now it's at the point where it's ready to grasp the concepts. But go into fractions with a positive attitude, even if in the past you've struggled with it, and you'll have a much better chance at succeeding. And I think you guys should succeed in this chapter. But what we're looking at in 4.1 is going to be estimating. And those in my class know that I'm not a real huge fan of this. At least this year I've talked about that some, but there is merit in being able to kind of estimate the answer in the head. It's just a lot faster and easier than coming up with an exact answer, and in some cases that's good enough. But want to start just with what's a fraction real basically. A fraction would be something like 3/5, and just made up a fraction. But with that, what I really want to point out is that the 3 is the numerator. And this is all review, so feel free to skip it if you're like, hello, we're starting here, I know this, but numerator is on top, denominator is on the bottom. If you have trouble switching those, it's corny, but maybe you could think of it kind of like building a house. Building a house, you start at the bottom and work up is the only way you can build a house. Denominator is first alphabetically, numerator is second, so maybe that would help. But you really need to have those terms down cold, or as you listen to notes as we're talking in class, it's just not going to make a ton of sense. As far as what those two things mean, the denominator, that's basically going to be how many parts the whole is broken into. So you could say one whole is broken into this many parts. And the numerator then, that's going to be how many parts you get. So you get, or you have, maybe I should say, this many parts. And for me, I tend to always think about pizza when I do this kind of stuff, and I don't know if that's what my teacher used in elementary school and it's just kind of stuck with me. But say you have a pizza, and you break the pizza up into 3 parts. So then 3 is going to be the denominator, that's the one whole is broken into this many parts. And say you get to eat this big slab and this big slab. Those there shaded in roughly in blue is going to be 2/3 that you just got, or you have 2 of the 3 pieces. So you just ate 2/3 of the pizza. If we have this one over here, maybe we could say we end up eating this many of the pieces. But exactly what that would be as a fraction, well, we have a whole pizza, we broke it up into 8 parts, and so we have the 1, 2, 3, 4, 5, 6, 7, 8, so 8 parts, and then I shaded in 4 parts there, so you ate 4/8 of the pizza. And when you reduce the fraction, you could look at this and be like, wow, you ate 4 pieces, yes, but you ate half the pizza is what you'd really say. And that would be the 4/8 as a reduced fraction. That 4 and 8, they're both even, so you could divide by 2 and then divide by 2 again. Or you could see that, well, this could be divided by 4, the numerator and the denominator both could be divided by 4. So if I divide them both by 4, 4 divided by 4 is 1, 8 divided by 4 is 2. And essentially what I really did is when I divided by 4 over 4, if you think about that, what is 4 over 4? That if you break something into 4 parts, you have 4 of them, you have the whole thing. So essentially I took the 4/8 and divided by 1, which is why 4/8 equals 1/2. Dividing by 1 doesn't change the value of something. So that's just real fast, kind of the, well, what is a fraction? Now we'll get into the actual estimating fractions, and we have a little bit of different process with the addition and subtraction rather than what we have with the multiplication and division. So breaking them up into two different Roman numerals. So Roman numeral 2, estimating with addition and subtraction. And for this, what the book recommends is they say take your fractions that you're going to be adding or subtracting and round them to one of three numbers, to 0, 1/2, or to 1. And then once you do that, then add or subtract mentally. Because especially if you don't have common denominators, if you start getting something like add 2/3 and 3/8, we're like, that's a lot of mental math to do that. But instead, if you take problems like that and combine them to these numbers, the 0, the 1/2, and the 1, those we should all be able to do in our head without too much difficulty. As far as how do we do that, how do we break those up, what you really want to do is you kind of want to look at it kind of like you have this ginormous number line. And we're going to say we have 0 down here, we have 1 down here, so right in the middle we'd have 1/2. And to round those numbers, you really just want to look at your fraction and say, well, which one of those is it closest to? Is it closest to 0, closest to 1/2, or closest to 1? And I'm just going to do some examples here. And say we have, my first example is 15/16 plus 1/8. And for many of you that might jump off the page that like, oh, it'd be easy to get common denominators, I can do this, and some of you already know the answer in your head. But if we're just going to try to estimate it, well, this 15/16, we have to look at this part here and say we broke this 1 up into 16 parts. We'd have 8 parts up to there, but basically, so then 8, this would be your 12, 13, 14, 15. So if we were to take that 1 and break it up into 16 parts, they'd be about this for a spacing. I wasn't really counting, so I don't even know if I have it quite right. But when we have it broken up into about 16 chunks, 15 of those 16 chunks is going to be right there. So that's 15/16. And maybe just try to write it kind of on the line. So 15/16 is going to be closest to 1. So what we'd say is, well, we're going to take and round this thing just to a 1 then. And if we want to add 1/8 to that, well, 1/8 is going to be, now we have to do kind of like every other number there. And so every other slab, but basically 1/8, in the middle you'd have 4/8. So 1/8 is going to be down kind of on this end. So 1/8 is going to be right about there. So if you have a 1/8, that's closest to 0, way closer to 0 than it would be to 1/2, which would be 4/8. So you just round that to 0, which then I probably should be, instead of saying equals, do the approximately equals to the little squiggly equals. And it's going to be real close to 1. And if you'd thought through that before, you would have come up with your answer being 1 1/16. So we're actually really close to what we would have had right there. Alright, for my second example, I want to combine 3/8, so 3/8 plus 3/5. And going to a number line and trying to break a number line up into a whole bunch of points probably isn't really practical. So what I would do instead is if I look at like a 3/8, well, it's not real close to 0, that'd be more like a 1/8 or something like that. Is it closer to 1/2? Well, half, well, if you have 8 parts, half would be 4/8. So 3 is real close to 4, so I'm going to take that first one and round it to 1/2. 3/5, same sort of thing, it's kind of there in the middle. Is it closest to 1/2? Well, half of 5 would be 2.5, so 3 is real close to 2.5/5. So I'd also say that one's going to be a 1/2. Now if we would combine those two together, we come up with an answer of 1 as well. And I think that's probably a little more practical rather than going through and constantly like going through and making a number line. Last example here is if I were to have like a 4 7/9. I'm going to change a couple things. One, I have a mixed number there, and also I'm going to make it subtractions. If I have 2 7/15. So how are we going to take those and combine them together? So half of 9 is going to be 4.5. So 7 is closer to 9 than it is to 4.5. So I'm going to take this first number and say, well, this 7 over 9 is really kind of like 1. So if I have 4 in that, that gives me, that's approximately equal to 5. And now here I have 2. Well, half of 15 is 7.5, so 7 over 15, yeah, that's really close to 1/2. So I'm going to say it's really, that's a 2.5. And 5 take away 2.5 gives me another 2.5 or another 2.5. So that would be the approximate answer for that one. So that's the short version of estimating with addition and subtraction. The last section of the notes today is estimating with multiplication and division. And this here, instead of always trying to round them to either 0, 1/2, or 1, which was a little different for that last one, I rounded the fraction part to 1/2 and then combine it to the number. Okay, anyways, estimating with multiplication and division. Instead, we're going to round them to compatible numbers. So round to compatible numbers. So round to compatible numbers. I'm going to say, and do the math. By that I mean do the multiplication or do the division. So our books talked about compatible numbers. So if you're doing a different book and you're not in my class, it might not make a ton of sense. But basically we're looking at what are numbers that could be multiplied or divided easily that are pretty close to those fraction numbers. And I'm going to look at a division one first. So I'm going to say example is 36 2/3 divided by 6 15/16. For the division ones, if you start with that first number, that's going to be a lot harder to go, because do I just round that to 37? Is that going to be a number that works with this thing over here? Should I round it to 40 or to 35? So what I would do is I would start with the second number and say, well, 6 15/16, that's going to be really close to 7. And if I start with that number, and now look over here at this one, is 36 2/3 close to something that I could divide by 7 nicely? And it is. That 35 divided by 7, we can do that in our head pretty easily. And for that, you know, it's like 36 2/3 is really pretty close to 35 in the grand scheme of things. So 35 divided by 7 gives me 5. So the approximate answer there would be the 5. For the multiplication, it doesn't really matter which number you start with. Although if you have the fraction, that might be the place to go, I suppose. But if I have 1/3 and 13, so 1/3 times 13, you could say it's 13 over 3 and then go and try to change it into a mixed number and so on. But instead I'm going to look at that and say, well, the 1/3, I don't really want to change that much. So I'm going to say that's just, I'm going to leave it as a 1/3. But now 13 is close to what number that I could pretty easily do that in my head. And you think, well, what number is divisible by 3? That's going to be a 12, which is pretty close to 13. So I essentially have 12 times 1, or 12 divided by 3, or 1/3 of 12. Anyways, you end up with your answer being 4, which is really close to the actual answer. The actual answer would end up being 4 1/3. But 4 is real close to that. And really it just kind of takes practice. So as you go through, I gave you the answers most likely for these. So go through, try one, kind of look at what the book said, figure out what they did if it doesn't make sense, and let me know if you need help. Good luck.